If you're looking for a technical tutorial on Apache SkyWalking, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is part of the Kubernetes series where we already have lots of episodes. How to collect metrics, what is SCADA, how to collect logs, what is vCluster, and more. Today's episode is the technical tutorials related to Apache SkyWalking. If you want to understand the limitation of Apache SkyWalking, then you should watch the dedicated episode to it. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see the various steps of our technical tutorial. We will start by reminding all the various components that would be used in our tutorial. Then we will go through the deployments and show what you should expect to have in your cluster. We'll start explaining how to instrument your code with Apache SkyWalking agents. Then we will look at the configuration required to observe your Kubernetes cluster. And last, we will configure the required component to observe Istio. To achieve this tutorial, I've been struggling a lot with Apache SkyWalking. So a few things would technically work and other won't. For example, the profiling, never been successful to implement that, to see the actual Zipkin traces, to see the OpenTelemetry traces. No idea how to do it. So if you find the solution to that, drop a comment below. I would be very interesting to hear how you did it and what's the actual solution. In this tutorial, I will try to instrument the well-known demo application called the Hipster Shop to get data using the standard agents of Apache SkyWalking. So we will look at agents for Java, for Python, for Go, for Node.js, and so on. We will also deploy all the right exporters to get details on the behavior of our Kubernetes cluster, and also from our service mesh. And today we will use Istio. So what do you need for this tutorial? Well, a couple of things. Of course, we need a Kubernetes cluster, no surprise, with one or more nodes, of course. We will deploy the cert manager, which is a requirement for the OpenTelemetry operator. And we, of course, we will deploy the operator because we will deploy our collector using the OpenTelemetry operator CRD. Of course, Apache SkyWalking will be obviously deployed. We will use Helm to deploy it. And we will add all the required components to observe a Kubernetes cluster with Apache SkyWalking. And that means kubestate metrics exporter, the node exporter, the event exporter from Apache SkyWalking. In this tutorial, I have decided to use Elasticsearch as a storage connected to Apache SkyWalking, and we will deploy also a rover to get some profiling. You see, I was not successful on that area. In top of that, we will have two demo apps running. So the Hipster Shop using the SkyWalking agents on one end, and on the other end, we will deploy the OpenTelemetry demo that will only rely on OpenTelemetry traces metrics. Yeah, the collector will also try to collect the logs from the cluster to send it to SkyWalking and see if we have some logs from our OpenTelemetry demo.
Like every tutorial that we deliver at Is It Observable, there is always a GitHub repository, and here we're looking at the one related to, of course, SkyWalking, because it's the tutorial for SkyWalking. So like explained before, you need a cluster. Here is the command to deploy your GKE cluster. We will need, of course, Istio. So you will have to deploy to get Istio CTL. It will be required because the script that we will run to deploy all the environments, so the deployment.sh, will mainly rely on this Istio CTL. So make sure you have Istio CTL installed in your machine, otherwise the script will fail. All right, so what do you expect from this environment? So if you do the namespaces, This is what you should have in terms of namespaces. So you can see that we have the cert manager, which is a requirement for the Open Telemetry Operator System. So those are two technical namespaces. We will find, of course, the Istio system namespace, where we'll have the control plane of Istio. And then the two main apps are Hotel Demo and Hipster Shop. Both of them has been labeled with Istio, so you will expect to get Envoy injected into the workload of the various applications. So, and then of course, here we are, we have SkyWalking, which is all the components related to SkyWalking. And the last piece is default. We'll have the collector and the various exporters required to observe, for example, Kubernetes and the collector pipeline to get the metrics from various components. So let's have a look that has been deployed here in the SkyWalking namespace. As you can see, we have the Elasticsearch. There's 3 replica deployed. We have the SkyWalking server here. There's 2 replica for the SkyWalking server, so the OAP server. The UI is here. So the UI is mainly to retrieve and visualize data. We have also a rover. So rover is the eBPF component that is supposed to do some profiling, but so far I've never been successful to do that. And we have the event exporter, same thing. It's here, but I don't know. Maybe on your end you will be able to get some value out of that. So that's what you should expect. Same thing from the service perspective on this namespace. You should find the Elasticsearch, of course, but the OAP server designed to receive all the various data coming from the various components that we are sending through gRPC. 11800 is the gRPC port, and the other one at 12800 is the HTTP port. And we will need to adjust this service to include Zipkin later on, because you'll see that the Envoy is trying to send the Zipkin traces through the traditional port of Zipkin. So make sure to add this port. We will do that in a few seconds. The UI is exposed on the port 80, and I have created a gateway rule from Istio, so the UI of SkyWalking would be exposed as well. So now, if you look at the pods running in the default namespace, you can see that we have the CubeStat metrics. So this is going to be required later on when touch-based Kubernetes. Same thing for the node exporter, also available for the Kubernetes perspective. And then we have a daemon set collector running with specific pipelines using all the scrap config that the SkyWalking community has recommended to use. So this is what you should expect. And then if we look at one of the applications, so Hotel Demo or the other Hipster Shop, you will see that here in this Hipster Shop application, we have at least, except for the Redis cart, we have 2 containers because we have the Envoy injected. Same thing, of course, for the Hotel Demo, because this is going to be, of course, running with 2 containers. So the proxy can fail. It's not a big deal because we don't need the proxy for our application. So once you deploy 2 things, like I said, the gateway will be exposed. So the Hipster Shop will be exposed out of the cluster. So this is how you can basically interact with the app. There is already a load test that is triggering at the top of the hour. So so if you want to have some traffic, make sure to reach the top of the hour, because the cron job will be launched with some load test against the online boutique, and you will see some information back in SkyWalking. And then the other gateway rule that has been created is the of course the SkyWalking UI, so where we can see the various components. Let's talk about the instrumentation. So what I have done here, and I have tried to, which was a bit difficult, is to instrument the Hipster Shop. So what I did here, if you find in the repo, you will find Hipster Shop, and then you have source, and source is all the various services of the Hipster Shop. I have removed OpenTelemetry or OpenCensus into those various services, and then I have tried to inject the auto instrumentation. So depending on the language, you have different way of doing it. So the ad services is in Java, card services in .NET. This one I didn't have the chance to instrument it. It was not successful. Checkout, front, and product and shipping is in Go. Currency is in Node.js, and we have recommendation and email services in Python. So let's start with Go. So Go, to achieve that, there is obviously two ways of doing it. There is one way which I decided to use, which is much more easier. And in fact, it's recommended by the actual documentation. So I didn't touch anything on the code. I changed the actual Docker file. So SkyWalking has a Docker image. So for each version of Go, so here in this particular case, it's Go 1.19. So I use the one that has the tag 1.19. And then you need to inject in the source the SkyWalking Go agent. And then when you build your Go app, you add this property tool exec, where you add the Go agent, and that will build the actual Go code with the actual SkyWalking agents. And then you just need then to launch the app, and you should get data from Go application. So Go is quite straightforward. It's not very complicated. Then you have Node. Node doesn't have this approach of getting the actual Docker image. So here you can see it's a traditional Node Node image. But what I've done here is I've added into the package, I've added the SkyWalking backend JS JavaScript. So there is two JavaScript library, one from the client perspective and one from the server perspective. In here, in this particular case, I've decided to use only the backend. We could extend it to also instrument the client. So then, which means when we launch the server, which is the server.js, what we need to do at the top of the function, we need to import the agent. So here, the agent provided by the backend JavaScript library, and then we simply need to start the agents, which I'm doing at the beginning of the main function. So that's really simple. But you'll see that even if I've done that, I don't get much details about the JavaScript services. So maybe I did something wrong. So if you have found the solution, let me know. I'll be very interested to know how you've been resolving this. For Python, so Python has two ways of doing it. There's one way where you use the Docker instance. So of course you need to select the right Docker, the Python runtime related to your application. So here it's 3.7. The other way around is using a traditional image and install the package with the SkyWalking agent. And then you just need to start, similar to Node.js in your code. You say start agent, and it will do the stuff. I tried both. The agent had required some library that was not compatible with this version of the Hipster Shop. So to save time, I've decided to use the Docker version approach. Maybe it's not the best one again. So if you found another way of doing it with the agent approach, let me know. I'll be very interested to see if you have successfully been instrumenting your code. Then, of course, you just simply need to add the various files, and then you don't do an entry point, because there is already an entry point provided by this agent, the Python agent. And at the end, if you do run Python, it basically added to the actual SkyWalking CLI Python CLI. So at the end, the Python is replaced by the agent CLI, so it should be instrumented as well. So this is how you do with Python. You don't need to touch much your code. You just need to use the right Docker image to build your application. For the other one is Go. So we talked about it. One thing which is important is look at the deployment files of the Hipster shop. So if you look at this file, Kubernetes manifest is the deployment of the Hipster shop. You will have the various images. So here, this is a recommendation is, if I'm not wrong, the Python. So most of the agent has common environment variables. So you need to set a name for the agent. You can put an instance name, but here it's the same one. I didn't do much. And then you need to define where you want to send the actual traces. So here it's on the gRPC port. One last aspect, if you scroll up to the ad services, I found. So for the ad services, which is Java here, I did not change anything in this container. What I've done here is to add an init container. So the init container is basically grabbing the Apache Java agent, which I'm doing here, and then I'm mounting volumes to that agent, and then I just launch the agent. And in the app itself, what I'm doing here, I'm adding a Java option where I'm asking to load the agent that is currently deployed. So it's a bit similar to the OpenTelemetry auto instrumentation agent that is available, where you can load an agent into the pod, into the container or in the application, and we're doing the same thing here. The difference is that the init container is done manually. If I were using the SkyWalking operator, this probably have been done automatically, but here in this case, I'm doing it manually. And last is for Go. So we can take, for example, front end, which is Go. You will see that there's another environment variable that I was forced to use because I thought that this is going to be defining the endpoint, and it was not doing it. Here in the case of Go, it has another naming called agent reporter gRPC backend service, and here I'm passing the service name of my OAP server to be able to receive the traces. So this is what I've done, and as a result of that, if we go back to SkyWalking, so you can go on the top here, general services, and we can click on services. So if I click here on services, I'm already here. We can see that I see most of the services except for a couple of the recommendation, which is in Python. I don't see it. And I don't see the card services because I have not instrumented it. And we can see data. What is great is you can jump into topology. So here I can see the actual topology with the various calls here done by the applications. Again, here, in few minutes, a load test will be triggered. So I may see other services going on, but which means if I go here on the trace, I can see globally all the trace generated. And so far is mainly health checks. So now it's, in my case, I have the load testing running. So if I go back now to the topology view, you can see that now I'm seeing the services that are for some reason not instrumented. So I can see the recommendation, I can see the currency, so I can see that the front end service is actually the most used one in this application. And of course, if I jump into traces, I see all the traces of all the services, get code and everything. But then, of course, we can do the same thing. Go back to one given service, so the front end. And you can see that now I have the app decks have changed. The service response times have increased because we have more load and everything. So this is giving you at least a good view on things. We can see the various endpoints, everything which is utilized. So then I can go to one given endpoint. Let's say I want to go to the POSC, which is when I pass an order. So I can see we'll have a few metrics coming in here. But what is interesting is looking at the topology view. So which is I really like, to be honest. This is an interesting thing. I can see the user is getting to a different path here, and you can see the postcard is here. So there's less traffic. So counting the number of traffic, so you can see the service flow. And then see where it's heading. It's heading to, for example, the postcards is getting to the product get product. So it's I like these visualizations, to be honest. So at the end, when you utilize their agents, you have a lot of interesting things related to this. So you can see, of course, the topology show you the same thing. But let me grab again the postcard, and we can see the traces. So here I can see the actual trace of the postcard, seeing where I'm spending time. I can filter for a given service, see the service involved. And then I can also see the logs. If I go back to the service, I see the logs here in general. All the logs here generated from the various services. So you can see that we have logs also coming in and collected by their agents provided by SkyWalking. Now that we've seen the actual instrumentation through the agents, by the way, a small comment, you see that there's no notion of the hotel demo, even if it's been sent. Yeah, for some reason, I don't know, we don't get much details. So let's see Kubernetes. So here we can see that we have a cluster here. We have the Kubernetes services as well. So you will see that there are a few requirements to do that. So if I click on the actual cluster, I will see the CPU resources, the memory, the various node status, the pod status. So you can see all the various information. So the number of services, the number of pod. There's no stateful set in my case. A number of nodes. So I can also go to one of the nodes available and look at the health of a given node. So I give you some details. Even if I have the event exporter deployed, I don't see any events. So that is quite interesting. So how do you achieve this? Well, a couple of things. So let me grab the repo back. So first, as you saw in the requirements, we have the kubestat metrics deployed and the node exporter and of course the advisor. So the Kubernetes monitoring rely 100% on the Prometheus metrics except from the event exporter. So you will see that there is a specific scrap config. So here, this is the collector that I'm using. This collector as a pipeline is I'm trying to collect logs as well. I don't see, it doesn't seem that the logs from even the hotel demo from the pods from the hotel demo is coming in. So I have no idea why, but at least I tried to see if I can get some things. Then the example of specific jobs. So here I have the scrap config with a job called Kubernetes nodes to get the nodes information. And then we do the same thing for the C advisor. We do where we get the node information. You can see that there's a specific path for the C advisor. We do the same thing for the Kubernetes service endpoints. So we to populate the service screens of Kubernetes. We do the same thing for Kubernetes services. And there is few relabeling rules. We do the same thing for the ingress, and then at the end I'm doing a Kubernetes pod to get details from the pod perspective. And at the bottom I have kubestat metrics as well. So here I'm collecting the kubestat metrics data, and I'm sending it back to SkyWalking. So what is this pipeline doing? Well, it's very, very simple. It is basically, there is some log transformation, which I'm not using so much. But what is important here is the traces and metrics, because here logs is sending it to SkyWalking, has a specific exporter, but for some reason it is not working. So I will try to change it with OTLP. So let me do it right away. For the metrics, I'm receiving OTLP. I'm using the Prometheus receiver. And as you can see, I'm basically sending it back directly to OTLP, because the metric endpoint for SkyWalking is the traditional OTLP endpoint, which is the gRPC port of SkyWalking. For logging, they have an exporter. It's been unclear to see, do I need to use it or not? So that's why I was using it. So maybe it's not the best way, but this is what you will need to achieve if you want to get some details. Aside of that, I also deployed Rover to get some eBPF details. But if you go back to, let me deploy this so we can see if our logs or we see any hotel demo logs. That will be interesting to see. You can see that there is a service screen. So this is basically populated through endpoints and services. Remember the job in this in our collector, there were a service and endpoint job, and this is basically coming from this specific scrap config. So it's getting the service information and populating it back here. I can see, of course, the pods that are related. So then I can go to the pod. You can see that we don't have logs from that container. And then the profiling here, you can see that it's not working at all. So I have no idea. If you had the chance to make this eBPF Rover component running, again, I will be very excited to get details about your experience. So for Istio, first thing, because we're going to utilize the Zipkin, we need to get the service of here it is, and we need to modify this service here so we need to edit this service to add the missing port, which is Zipkin. So I'm going to add a name, Zipkin. Port, it's going to be 9411, if I'm not wrong. Let me double check with the settings that is in the Istio operator deployments. I'm using the Istio operator, so 9411, yeah. So here it is, and then protocol is TCP, and the target port is 9411. All right, so now that this is done, we can now check the service, and we have the Zipkin port added to our SkyWalking server. So a few things. To be able to observe your service mesh, let's look at the Istio operator. So the way I have deployed Istio. I use the Istio operator. Again, this is not recommended, but just to deploy, it works fine because it will configure the mesh config on the fly. What I'm doing here is the default config will be putting Zipkin, enabling Zipkin for tracing, using the Envoy access log services. So we're enabling this, and we are sending the address to the gRPC port of our SkyWalking server. We do the same thing for the Envoy metrics to send it directly to the SkyWalking server. Then what we do here, we enable Prometheus, we enable the access log service, and we enable tracing, and the rest is not interesting, but it's there. It's in case we use the collector, but this is the most important one, the default config, because this is the one is gonna be sent to the various collectors. So that's one thing. You need first to configure Istio to get the Envoy metrics sent directly to the SkyWalking server, the Envoy logs sent directly to the SkyWalking server, and Zipkin from the Envoy sent to the SkyWalking server. Then to get the control plane health, again, we're going to go back to the collector, and it's going to be another scrap config. Here in this scrap config, we scroll up to the Prometheus receiver. You will see that there is an Istio D job, which is Istio monitor, which is here, Istio D monitor is basically grabbing Istio D, HTTP monitoring port, and we'll send it to SkyWalking. So this is going to be required, which means if you go back to, again, SkyWalking, and I open the service mesh menu, I can see the control plane. So you can see that we have, for some reason, I don't know why I have two control planes. I have the Istio D and the showcase, but here if you open Istio, one of them, you will have the same metrics. It's just duplicated. I can see the actual health of Istio with the time to propagate the settings to the envoy. So that's more on the control plane health. Then you have data plane, and data plane show you the various component having envoy injected. So you can see that we have the OpenTelemetry demo. And if I pick one of them, let's say where I know that we have some ad services has been instrumented, we can see the instances of them. And then you can see EBF profiling. Of course, this won't be working, so I can try to do some profiling, but it won't work. So here, if I click on this service from an envoy perspective, I would see the heap, the connection use, so the metrics provided by envoy. This probably, though, the other ones I didn't enable those metrics, so that's why I don't have it. And then normally, if you click on logs, I should see the logs from this specific envoy, but I don't know, for some reason I don't see it. Let me check if I see something, but yeah, I don't see it. And then for profiling, same thing. It should be done by the rover, but for some reason it's not working. Then if you click on the services, you can see all the various services created. So if I pick one of them, let's say this one, I get back to the mesh services with the instance, and I can see the data. But here it's the OpenTelemetry demo, so I don't have much details about it. Here, Zipkin trace. So here I should see normally first the topology view based on the data coming from the envoy, but it's not created. So I've been trying a lot of configuration and never been seeing the topology view, so should technically be able. And then I should see the Zipkin traces, which I don't. And again, I've tried different configuration, different settings, and none of them has been working so far.
That's it for today's tutorial on Apache SkyWalking. As you can see in this tutorial, Apache SkyWalking has lots of interesting features, but it is mainly limited if you use their agents. No, I was not successful to see any of the OpenTelemetry stack that was being ingested or sent to Apache SkyWalking. So if you found a way of seeing those traces or metrics from OpenTelemetry, let me know. I'm very eager to resolve this, because at the end, I never been successful to see anything about OpenTelemetry or even in Zipkin in Apache SkyWalking. The service mesh mainly relies on control plane and metrics from the envoy. A couple of interesting things. I was a bit disappointed, to be honest, on what we see in Kubernetes. So we see the cluster view, we see the nodes, we see the pods, but there's no real view on workload or namespaces. So if you have any, or even networking, so there are a few areas like this, which is you have details, but not the one that you expect, especially if you operate a Kubernetes cluster. On a service mesh, it sounds promising, but again, no way of get the topology view, because I was really eager to see it. And then if I was able to see it, deploy more, let's say, use features from the service mesh, like the request timeout or rate limiting, and to see if those were visible in those topology view. So at the end, Apache SkyWalking sounds very promising, provide a lot of great things. But again, keep in mind that if you want to use it, you would have to be stick to the usage of their agents. All right, if you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode. Bye.